Chapter 2 is Matter Around Us Pure, Class 9th. This is a very cool way of going through the whole chapter and its salient points. I hope it benefits all the students out there. Thank you. And before we proceed further, this is a humble request. Please subscribe to my YouTube channel, Krishna Classes. Matter is divided into two on the basis of physical classification and chemical classification. Matter is divided, and on the basis of physical classification it is divided into three categories: solid, liquid and gas. On the basis of chemical classification, matter is divided into pure substances and mixtures. Now pure substances are again subdivided into elements and compounds. Elements are then subdivided into metallics, metalloids and non-metallics, whereas mixtures are of two types: homogeneous mixtures and heterogeneous mixtures. Compounds are again categorized into organic compounds and inorganic compounds. Pure substances and mixtures. Pure substance is a substance which consists of a single type of substance, whether it is an element or a compound. Examples are iron, copper, hydrogen, oxygen, water, sugar, common salt. Mixture is a substance which consists of two or more pure substances. Examples are seawater, minerals, soil, air, sand and salt, sugar in water, salt in water. Homogeneous and heterogeneous mixtures. What are the differences? Let's go through them. Homogeneous mixture has a uniform composition. Heterogeneous mixture has a non-uniform composition. Homogeneous mixtures particles are not visible by the naked eye. Homogeneous mixtures particles cannot be separated by filtration, whereas heterogeneous mixtures particles are visible by the naked eye and they can be separated by filtration. Homogeneous mixture is stable. This means that even if it is kept for a long time, its particles do not become suspended, whereas a heterogeneous mixture is unstable. Homogeneous mixture does not show Tyndall effect, that is, the path of a beam of light is not visible in the mixture, whereas in heterogeneous mixture the path of a beam of light is visible. Examples of homogeneous mixtures are mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water, etc. Whereas heterogeneous mixtures examples are mixture of salt and sand, mixture of sulfur and iron fillings, mixture of oil and water, etc. True solution. A true solution is a homogeneous mixture of two or more substances. A solution has a solvent and a solute as its components. The component in the larger amount is the solvent and the component in the lesser amount is the solute. Examples: solution of salt in water, solution of sugar in water, iodine in water, that is called tincture iodine, soda water, etc. What are the properties of true solutions? Let's go through them. True solution is a homogeneous mixture. Its particles cannot be seen by the naked eye. The solute particles can't be separated by filtration. The solute particles do not settle down and the solution is stable. The particles do not scatter a beam of light through it, which passes through it, and the path of light is not visible in the solution. In short, we can say that a true solution does not show Tyndall effect. What is a colloidal solution? A colloidal solution is a heterogeneous mixture of two or more substances. Example: mixture of starch in water, Mixture of egg albumin in water, milk is again a very good example of colloidal solution, air containing dust and smoke, etc. Now let's go through the properties of colloidal solution. Colloidal solution is a heterogeneous mixture. The particles cannot be seen by the naked eye. The solute particles cannot be separated by the filtration. The solute particles do not settle down and the solution is stable. The particles scatter a beam of light passing through it and the path of light is visible in the solution. In short, we can say that colloidal solution shows Tyndall effect. Suspension again is a heterogeneous mixture of two or more substances. Example, solution of sand in water, solution of chalk powder in water. What are suspensions? Suspensions are mixtures in which insoluble particles are suspended in a liquid or a gas. Suspensions examples are flour in water. Like other liquids that need to be shaken well before use are called suspensions. Muddy water taken from the swamp is yet another example of suspension. Suspension, as we read earlier, is a heterogeneous mixture. The diameter of its particles is larger than 1000 nm. The suspended particles precipitate if it is left for a short time without shaking, that is, they settle down. The suspended particles can be seen by the naked eye. The suspended particles can be separated by filtration because filter paper can hold the suspended particles while the water passes through it. Now, Tyndall effect. When a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of light becomes visible in the solution. This effect is called Tyndall effect. Tyndall effect can be seen even in a dense forest due to scattering of light by water droplets in the mist. Here are two images which show what happens when a beam of light is passed through solution, colloid and suspension. Solubility. Solubility is amount of a solute that can dissolve in a given amount of solvent. Unsaturated solution is a solution which contains less than the maximum amount of solute, which it also means that an unsaturated solution can dissolve even more solute. Saturated solution contains the maximum amount of solute that can be dissolved in it, and it has undissolved solute at the bottom of the container. Concentration of a solution. The concentration of a solution is the amount of solute present in a given amount of the solvent or solution. Percent by mass is equal to mass of solute upon mass of solution into 100. Percent by volume is volume of solute upon volume of solution into 100. Now there are different methods of separating the mixtures, particles or components. Let's go through them. Separation method and what it separates. Chromatography is used for separating compounds in a solution with same properties. Filtration is used for solids or groups of solids and liquids in a mixture. Magnetic attraction for separating magnetic substances from non-magnetic ones. Crystallization is used for separating dissolved solids in a solution. Simple distillation for liquids in a solution. Fractional distillation is used for separating mixture of miscible, means mixture of those liquids which mix among themselves, which are dissolved in each other. Separating funnel is used for immiscible liquids, or we can say undissolved liquids. Sublimation is another way of separating substances, but it separates only those substances which sublime. Evaporation is used for separating solids that cannot decompose when heated in a solution. Centrifugation is used for separating denser particles and lighter particles. Evaporation. Evaporation is a process in which a liquid changes into gaseous form on heating, allowing the liquid to evaporate, leaving the soluble solid behind. Here there is this diagram in which you can see the process used for evaporation. Centrifugation is the method of separating denser particles and lighter particles from a mixture by using a centrifuging machine, and this method is called centrifugation. Example, if milk is put in a centrifuging machine and spun rapidly, the cream separates from the milk because cream is less dense than milk. Decantation using separating funnel. This method is used for separating a mixture of immiscible liquids. Liquids separate into different layers depending on their densities. Decantation. We use this technique to separate two immiscible liquids. Oil, less dense, is above water, as can be seen in the diagram. Opening the tap, water is falling down, drip, drop. When oil is going to escape, we turn off the tap. Sublimation is used to separate a mixture of sublimable component from a non-sublimable component by heating the mixture. Example, if a mixture of ammonium chloride and common salt is heated, the ammonium chloride sublimes and can be cooled and solidified and collected, and salt is left behind. As you can see in the picture, ammonium chloride solidified is getting collected on the inverted funnel. Ammonium chloride funnels do not escape out of the funnel. For this purpose, we have put a cotton plug on it, and mixture of ammonium chloride and salt is put in the china dish, and a burner is used for warming it up, for heating it up. Chromatography. Chromatography is again a process used for separating, and there are many kinds of chromatography. Here we are discussing paper chromatography, which is used to separate and identify the different colored components in mixtures. Paper chromatography, components in the mixture which are more soluble in the same solvent travel further on the chromatography paper. Different colored components will appear at different locations because they travel at different rates. It can be used for testing food colorings to ensure that a product is suitable for consumption. It can be used for detecting the presence of drugs in urine samples. Distillation. This method is used for separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. Here in this picture we are seeing how to separate a mixture of acetone and water. Simple distillation is used for separating a mixture of two miscible liquids which are having sufficient difference in their boiling points. Now this is to be kept in mind that simple distillation can only be used for liquids which are having sufficient difference in their boiling points. Example, if a mixture of acetone and water is heated in a distillation apparatus, the acetone, which has a lower boiling point than water, first boils and cools and condenses and is separated from the water. Fractional distillation is used for separating a mixture of two or more miscible liquids whose difference in boiling points is less than 25 Kelvin. Fractional distillation is used for separating the components of petroleum, separating the different gases from air, etc. Separation of components of air. The components of air can be separated by fractional distillation. Air is compressed by increasing the pressure and cooled by decreasing the temperature to get the liquid air. These are the two processes which are used to liquefy the air. First, it is compressed by increasing the pressure, and then it is cooled by decreasing the temperature. The liquid air is then allowed to warm up slowly in a fractional distillation column. Purification of solids by crystallization. First, impure solid is dissolved into solvent, then it is stirred. The impure solid is dissolved, then it is heated so that most of the solvent gets evaporated, and then the crystals form when the hot solution is allowed to cool. Then the cold solution is poured off on a filter paper to obtain the crystals. The crystals may be dried by pressing them between sheets of filter paper. Matter is again classified into pure substances and impure substances. Pure substances are divided into elements and compounds, and an element is a pure substance which cannot be broken down into other substances by physical or chemical means. There are over 100 known elements, 92 of which occur naturally. Each element has a unique name and symbol. The four most important elements to living things are carbon, hydrogen, oxygen and nitrogen. Elements are divided into three categories, that is metals, non-metals and metalloids. Metals and non-metals have many differences, and some of these differences are on the basis of appearance. Metals are shiny, non-metals are dull. Most of the metals are solid except mercury, which is a liquid at room temperature. Non-metals are solids, also some of them are gases, and one bromine is a liquid. On the basis of density, we can say generally metals are highly dense, they are strong, metals are malleable, whereas non-metals are low in density, they are weak, they are brittle. Conduction of heat is a parameter on which we can say metals are very good, whereas non-metals are poor, they are insulators. Conduction of heat is something on which again metals prove to be good, whereas non-metals are poor, they are insulators apart from graphite. Magnetic materials, only iron, cobalt and nickel, these are the metals which are magnetic. None of the non-metals is magnetic, and metals make a sonorous sound, they make a ringing sound. Non-metals make a dull sound when they are hit. Metalloids, physical properties of both metals and non-metals are shown by metalloids. Some are shiny, some are dull. They are somewhat malleable and ductile and can conduct heat and electricity, at a lesser level than metals. Boron, silicon and arsenic are some of the examples of metalloids. Compounds. It is a pure substance which is made of two or more different elements and can be separated into smaller substances by chemical means. Atoms form compounds to become more stable. Examples are hydrogen oxide, that is called water, carbon dioxide, carbon monoxide, sodium chloride, aluminium chloride, magnesium oxide, lithium oxide. Differences between mixtures and compounds. Mixture is composed of two or more elements or compounds mixed together, whereas compound is made of two or more elements which are chemically combined together. Mixture can be, composition of mixture can be in any ratio. Let's give an example here. Even if you mix a tablespoon of salt in water, it will be a mixture. If you mix 2 or 3 tablespoons of salt in water, it will again be a mixture. But if we take water, example of water, it always contains 2 atoms of hydrogen to 1 atom of oxygen. The composition of the components is in a fixed ratio in a compound. Mixture shows the properties of the components. Compound shows completely different properties than the components. The components of a mixture can be separated by a physical process. The components can only be separated by chemical methods in a compound.